There are numerous ways to get data into a parameter in TouchDesigner. In this video, I'm going to go through the various options and which ones it makes sense to use in different scenarios. If you have some experience in TouchDesigner, you may know some of this already, but it might still be useful to learn about the pros and cons of the different options. As with most things in TouchDesigner, there are a lot of different opinions on how this should be handled. I'm going to go through how I do things, but other people may have reasons to do things differently. That said, let's get into it. Each parameter is in one of 4 different modes which control where its value comes from and how it behaves. You can get to those by expanding the parameter and the parameters dialog, and you're going to get these 4 checkboxes here. Clicking on these allows you to switch between the different modes, although for some of the modes you need to do some other stuff to get them to work other than just switching them. The 4 modes are constant, expression, export, and bind it. Constants are just numbers or pieces of text. So you can edit those usually with a slider or by putting values in here or using the value ramp, any of those things. Anytime that you use the mouse or keyboard to set the value of a parameter, you're putting that parameter into constant mode, unless bindings are involved, which I'll cover later. Even if a parameter was in some other mode, as soon as you start editing it with the mouse, it's going to pop back over to constant. Expressions are a way to use a bit of Python code to produce a value for a parameter. You don't necessarily need to know Python well in order to be able to use them, though it can be handy. You can put a parameter into expression mode with this second checkbox, the blue one there. And then you could put in an expression like 1 divided by 3, or you could even use things from the TouchDesigner application like this abstime.seconds, or call Python functions like math.sign here. And for that one, notice how this is continually updating on every frame. Expressions can tell when they involve getting data from something that might be changing, and they're smart enough to figure out when they need to be updated automatically. There are some rare exceptions to that, but in general, that's true. Expressions can also access parameters or other properties from other operators. So for example, on the circle here, we can reference the amplitude parameter from our pattern operator here with this expression OP parentheses quote the name or path of the operator in question, and then parentheses quote dot par dot amp, and that's the name of the parameter there. And so when you mouse over each parameter, it's going to show you the kind of official name, which is often just like a shortened or abbreviated version of what's being shown in the main label there. So when we change that other parameter over here, then we can see how it's also updating the one on our circle top. Note though that the reverse of that is not true. So over on the circle, if we were to change one of these values here, the minute that you do that, it's going to just get rid of that expression and switch it back over to constant mode. And that's going to break the connection between the 2 operators. You can also reference other parameters from the same operator. So here we're using an expression in the center y to refer to whatever the value of the center x is. So if we change one, then it's going to automatically change the other. It may not necessarily update in the UI at the same time as you're kind of dragging things around, but it is under the hood, it is actually doing that. We can also use expressions to get values from chops. So here we have an example where we're using an expression to get whatever the number is, the value of this FPS channel from this perform operator. So similar to with the other expression there, you can't really edit this from this end. This is basically just pulling the value out of that chop channel. For chops that have multiple samples in them, like this pattern chop where we can see like a graph instead of just a single number, there's more complicated expressions that you can use to kind of pick out different parts of that, but I'm not going to get into detail about that in this video. There are a ton of other things that you can do in expressions, and I'm not going to get into a ton of detail about all of that. For this video, we're going to focus on just pulling the value of another parameter from somewhere else or from the same operator and grabbing the value of a chop channel. In both of these cases, we can describe this expression as referencing, in this case, the chop channel, or the expression here is referencing this other parameter. The easiest way to set up a reference expression between two parameters is to drag the source parameter onto the kind of the destination, and it's going to pop up a menu, and then you can choose the reference option. And then that's going to automatically add an expression in here that references that parameter. Note that there isn't a special reference mode. It's basically just a shortcut in the UI for filling out an expression. You can then change this expression to include other stuff, like if we wanted to multiply it by 4, then when we change the rotation over here, it's going to do 4 times as much rotation on that other one. There is a similar option that you would get if you drag a chop channel onto a parameter. So it will show chop reference as one of the options there. So then we could connect that one up, and then you can have chains of references, but you can't have a cycle in that. So if you have a loop, that's going to cause issues. Next up are chop exports. So we saw that a little bit when we were dragging this parameter here. One of the options here is export chop. So we can reproduce that here. If we take this channel, drag it onto our noise, drag it onto this amplitude parameter and choose export chop, it's going to do a few things. First, it's going to switch on this export flag on the chop, and then it's going to add this hidden table, and that's going to control how that export functions. Generally, you don't really need to go into this table and mess with it. It's typically just updated by the network editor automatically, but you can if you want to. The big conceptual difference between a chop export and an expression that's referencing the value of a chop is that an export is more like a push, whereas the reference expression is more like a pull. So what I mean by that is that it's the source of the value that decides whether this export is going to happen. So this flag here, if you switch that off, then that parameter just goes back to its normal default state. So switching that on, it gets the export applied to it, and then you switch it off, then it just goes back to whatever it was. There are 2 different sources that exports can come from. One is chop channels, and then the other is a table DAT, which we're going to cover in a bit. You can't directly export from a parameter to another parameter, although if you wanted to, you could use a parameter chop to get that parameter's value into a channel and then export that. You don't necessarily have to do your exporting from a null, although it's almost always a good idea to do that instead of directly exporting from somewhere else. In addition to this style of chop export, there's a really handy feature that you can use to automatically push multiple channels to different parameters and even to parameters on multiple other operators. On every chop in the parameters on the common page here, there is this export method, and by default, it's going to be dat table by index, but you can change it to channel name is path : parameter. And what that does is it takes any channel that's in that chop and it looks for that colon, and the first part of that is going to be the path to an operator, or in this case, just a name since it's right next to it, colon, and then the name of a parameter. And when the export flag is on here, it's going to automatically push that value onto this parameter. You can even use wildcards to push the same parameter onto multiple different operators. On the common page of the parameters, there is this export route setting. So this is where it will start interpreting that path as being relative to. So by default, it just goes to the parent. So that's why we could just use the name of this operator, and then relative to the parent, that's the path to this. But we could also use a pattern here where we could say Taurus star, and then if we turn on that, it's going to push to any operator that matches that. And you can use this with more than one channel. You can use this to push, a parameter to a bunch of different operators, or, a bunch of parameters to one operator, and so on. So this is a great way to take a value from one central location and kind of send it out to a bunch of other places. The other type of export that we can do is from a DAT table. When the export flag is on a DAT, and it's a table and it has the expected column names, then it's going to treat each row as basically an export, which can push to multiple operators and potentially even multiple parameters. So for the path, we could put just the name or path of a single specific operator, and we say that we want to push it to the text parameter. One thing to keep in mind, the value here, if you're going to put in a piece of text, you need to wrap it in quotes. And when we do that, then it's going to push that value onto this parameter. We can even use a pattern in the path. So we would say to push to both text2 and text3, and to the value to use parameter. And this is showing that we can use an expression in there. So that expression ends up getting evaluated separately on each operator that it gets pushed to. So if we go to text2, then it's using that expression here effectively. And, that part of that includes looking at the value of its own text parameter. And that's going to produce one value here, but over on text3, well, it's going to produce a different value because, in this case, it's looking at its own text parameter. It's also worth noting that this doesn't necessarily have to be a table DAT. It can just be any DAT that contains a table. So if you wanted to have a null here, you could export from that instead. And then this is going to show just an example of how the network editor picks up on issues when you have conflicts between exports, and it will prompt you to automatically switch off the setting to kind of resolve that conflict. As you can see here, we're using a null here, so there could be other things upstream of this that produce this table. So you could use that to kind of dynamically generate a set of exports that get pushed onto different operators. Next up are bindings. Bindings are typically between parameters, although there are also ways to use them with the bind chop or with an editable cell in a DAT table. But for this video, I'm just going to stick to parameter bindings. Bindings are different from the other types in that they're bidirectional. So that means that you can have two parameters. Here we've got value parameter here, and then we have another operator with another parameter here, and this parameter is bound to the one on the other one. In that relationship, one of those sides is considered the master, and for those, it's not going to show itself in bound mode. It's just going to be constant. And for the ones that are kind of a binding back to something else, they're going to have this expression in here that is going to refer to a specific parameter on that. But because this is bidirectional, we can update it from both sides, and it's going to update to make sure that they all stay in sync. In many cases, the expressions that you see in the binding here may look similar to what the kind of expressions that you could use just for like a regular parameter expression, but there are stricter rules about what can go in there. And basically it has to point to a specific parameter. So you couldn't like add a, divided by 2 or something at the end of that, because then it's just producing a number. It's not, pointing to a parameter. One of the most common uses of bindings is for UI widgets. So in this case, we have a operator here that has this scale parameter, and then we have a slider widget, and it has its own value parameter, and this is bound to the one on the box. So when we change this, it will update the box. And because it's a slider, part of how it handles the mouse interaction is that when you change it here, it updates its own value parameter. And because that's bound to the one on the box, that one gets updated too. And because it's bidirectional, the box can also update the slider. So it goes both ways. Now that we've covered the different parameter modes, we can talk about how to choose between them. So we'll start with expressions. So when would you use an expression to reference the value of another parameter or a chop channel? One of the big advantages of expressions is that they can include other stuff beyond just grabbing the value of a parameter or a channel. So, if you want to have a relationship that isn't just a one-to-one same value between things, you can use whatever bits of math you want in there. You could reference multiple parameters, divide one by the other, and so on. So if you need to be able to do things like that, you pretty much always have to use an expression. So as we showed earlier, expressions are a one-way connection. They pull values from other places to use them to produce a value for this parameter. If you want the ability to be able to change it from both ends, then you're going to have to use a binding. Years ago, expressions used to be less efficient than the other modes, so you might see old advice in the forum about avoiding them, possibly posted by myself. But at this point, they've optimized things a lot, so it's often just as efficient as an export. There is a special subset of the kinds of things that you can put into parameter expressions that get special treatment where they get optimized. So it doesn't even have to run Python code. It just knows inherently that this is a parameter multiplied by a constant number, and it can kind of just run that faster than if it was like actually running it as Python code. If you mouse over a parameter, you'll be able to see whether it is optimized or not. There is a page on the wiki that gets into a bunch of detail about what kinds of things get optimized and what kinds of things don't. So take a look at that if you're curious. Though often, even if it's not technically optimized, it's usually still pretty fast unless it's calling really heavy Python functions. A big downside of expressions is that the network editor doesn't really keep track of them in the same way that it does for exports or bindings. So when we have an expression here that's referencing this other operator, the minute that we rename that expression breaks, we get an error. So it doesn't really know that it should update this expression automatically. And it's doing that because, you could even do something where you're looking up the value of another parameter, get the path to which operator you grab, so all kinds of things that you can do in there. So it doesn't really know how to be able to update that automatically. Next are exports. Exports are a great way to have a centralized place where you're pushing values out to a bunch of different things. So one of the cases that I tend to use that for is if you have some timeline animation and it's controlling properties of a few different operators, you can set up your animation, and then if you name the channels to match the path and name of those parameters, you stick a null chop at the end and switch on its export flag, then it will push those out to the various operators. And that gives you the ability to edit both of these kind of together, and that gets really handy if you're coordinating animations across a whole bunch of different operators. I also like to use them in cases where I want to make it a little bit easier to switch between sometimes kind of pushing an automated value onto a parameter, but sometimes just going back to setting it manually. So in this case, I've got an LFO that's controlling this parameter of a rectangle, but if I want to go back to, just manually changing it and stop using the LFO, I can just switch that off and then I can edit it here freely. And then if later on I want to go back to using the LFO, you can just kind of pop that back on. One of the downsides of exports is that you need to have a chop or a DAT involved, so they aren't really useful for directly linking one parameter to another. Another downside of exports is that since they're pushed out from the source, if you make a copy of an operator that's getting an export from somewhere, then that export doesn't really carry over to the other one. Whereas if there was an expression there that was grabbing this channel's value, then you make a copy of that, then it's still going to have an expression grabbing that same channel value. So you'll see this popping up with, export not found for parameter size. So it knows that it was getting an export from somewhere, but that export is no longer attached. In general, the network editor is fairly good at detecting when an export is being broken by something being renamed and kind of prompting you to adjust that, but it doesn't necessarily always get that correct. Last, there are bindings. Bindings are critical for UI widgets that are linked to other things. So this scenario here where we have a slider that's controlling a parameter somewhere, this is really the best possible way to do that. So the main advantage of bindings is that they're bidirectional. But for me, at least, the main downside of bindings is also that they're bidirectional. And what I mean by that is that at least in stuff that I build, I like to think of there being kind of a meaning to something using a binding. So let's say we have a component here that has this, thing size parameter on it. So if we pop in here and then just open the parent parameters, then we can see how we're using this thing size to control, both parts of the radius of the circle here. And we also have a rectangle that's being positioned to be on the right edge of that. So whenever we change this, then, those things both update. Now, you might be able to make a case for this example that there could be a reason why you'd want to go inside this network and change, that setting from the radius here or something. Although you might notice that the UI doesn't automatically show the new value until you let go of the value ladder, but it is actually staying in sync. But then for the rectangle, this position here, if you wanted to then move it a little bit off to the side or something, it doesn't really make sense to be able to update the size of the thing from this center position, right? This kind of logically should be a pull from that size and not, a one-to-one linkage with it. So conceptually, there is a lot of value to having one thing being kind of the source of the setting and then other things referencing that. I did a recent video on this called Single Source of Truth, if you want to get more details on that concept and why that's important. But with bindings, that relationship becomes less clear. But for something like controlling a slider and a parameter, then it totally makes sense. On the plus side, TouchDesigner is able to track them better, and it can automatically update things if you rename them. So if I were to change the name of this parameter here, then you can see how it knows to automatically update those. And it's able to do that because, this expression here is just a direct reference, and it can really easily tell that that's the thing that it was pointing at. It doesn't have to parse through a bunch of math and figure out which parts of that refer to parameters and which ones don't. So it is pretty useful for being able to do that. So overall, I'd say that I will use a binding if there's a reason for two parameters to be linked and then to be able to kind of change it from either end. I'll use an expression with a reference if one parameter is sort of in charge and another one is following it, or if I want to have some, math or other stuff in there that doesn't just grab the value, it does something else with it. For exports, I use those when I want to push values out from a centralized place to several other places, or when I want to put a chop value into a parameter, but then be able to easily switch that connection on and off. So hopefully this was helpful. If you disagree with any of this, leave a comment about what you prefer and why. I'm always open to hearing different opinions about this stuff. If you like this video and you want to support me making more of them, consider subscribing to my Patreon. You'll get exclusive downloads, early tutorial access, and a bunch of ATK stuff. And even if you don't feel like paying, you can subscribe for free as a way to get RateDK announcements. Anyways, thanks for watching, and make sure to like, subscribe, and turn on that notification setting.